Hi everyone. Continuation of the last class. Now we are going to evaluate the inverse Laplace transform by decompose the given fraction into partial fractions. Method of partial fractions. I think all are aware about the how we are decompose the given fraction into partial fractions or simple fractions. Right. This is the one of the way to evaluate the Laplace inverse Laplace transform of the given function. Right, yeah, yes, we know that 3s plus 7 divided by s square minus 2s minus 3 can be written as 3s plus 7 divided by s square minus 3s plus s. Right, it is s minus s plus 1 into s minus 3. S square minus 3s plus s minus 3s. Here it is minus 3. So s square minus 2s minus 3. So two fractions are not repeated. So a divided by, we are writing a divided by s plus 1 plus b divided by s minus 3. So this is equation number 1. Now you know that you take out the LCM and cancelling, you can write it 3s plus 7 is equals to a into s minus 3 plus b into s plus 1, one of the way. Or direct I am writing multiplying 1 with s plus 1 on both sides and taking s tends to minus 1. S tends to minus 1. So it becomes, if you are multiplying with is multiplying 1 with s plus 1 on both sides and taking s tends to minus 1. So it becomes here s plus 1 get cancelled, only a we have, as when we are multiplying with s plus 1 into b divided by s minus 3 and s is tending to minus 1 plus 1 0, that second term completely 0. Yes, what we have, a is equals to limit s tends to minus 1. Yeah, we have 3s plus 7 divided by s plus 1 get cancelled, we have s minus 3, which is equals to 3 into minus 1 plus 7 divided by minus 1 minus 3. So 3 into minus 1 minus 3 plus 7, that is 4 divided by minus 4, which is minus 1. Next, multiplying 1 with s minus 3 and taking s tends to 3. So it becomes, here it is a b only we have limit s tends to 3s plus 7 divided by, here it is s minus 3 get cancelled, we have s plus 3 only. Here it is we don't get this term, so when we are multiplying with s minus 3 into a divided by s plus 1, s tends to 3, it becomes 0, only second term we have. So which is equals to 3 into 3 plus 7 divided by 3 plus 3. 3 into 3 9 plus 7 16, 9 plus 7 it is 16 divided by 6, which is 8 by 3. Sorry, here it is when we are multiplying with s minus 3, we have s plus 1 here. So here it is 3 plus 1 here, 16 divided by 4 here, so which is 4. Okay, therefore a is equals to minus 1, b is equals to 4, and substitute these a is equals to minus 1, b is equals to 4. So it becomes, which is equals to minus 1 divided by s plus 1 plus 4 divided by s minus 3. Now taking the inverse Laplace transform on both sides, inverse Laplace transform of 3s plus 7 s square minus 2s minus 3 is equals to L inverse of minus 1 divided by s plus 1 plus 4 divided by s minus 3. L inverse of 1 divided by s plus 1 plus 4 into L inverse of 1 divided by s minus 3. You know that this is a standard principle, e to the power of minus t plus 4 into e to the power of 3t. This is the procedure. Next. Next one is L inverse of s square divided by s plus 1, s plus 2, s plus 3. S plus 1, s plus 2, s plus 3. S square divided by s plus 1, s plus 2, s plus 3 is equals to a divided by s plus 1 plus b divided by s plus 2 plus c divided by s plus 3. Say this is equation number 1. First one, multiply 1 with s plus 1 and taking s tends to minus 1. So these two terms become 0, only we have. Therefore limit s tends to minus 1, s plus 1 get cancelled. We have s square divided by s plus 2 into s plus 3. So which is minus 1 squared is 1, 1 divided by minus 1 plus 2 it is 1, minus 1 plus 3 it is 2. So which is 1 by 2, a is equals to. In the same way, it's multiplying with s plus 2 and taking s tends to minus 2. So we have b limit s tends to minus 2, s square divided by s plus 1 into s plus 3. So minus 2 squared is nothing but 4. Minus 2 plus 1, that is minus 1, minus 2 plus 1, minus 2 plus 3, it is 1. Here it is minus 2 plus 1, it is minus 1, minus 2 plus 3 is 1, which is equals to minus 4. B is equals to minus 4. Next, multiplying equation 1 with s plus 3 and taking s tends to minus 3, will get c. C is equals to limit s tends to minus 3, s square divided by, we don't get this term, only s plus 1, s plus 2. S plus 1, s plus 2, so which is equals to minus 3 whole square. Minus 3 whole square is nothing but 9. Here it is minus 3 plus 1, that is minus 2, minus 3 plus 2, that is minus 1, which is equals to 9 by 2 we have. So if we are substituting this from this equation, we can write it or taking inverse Laplace transform also. S square divided by s plus 1, s plus 2, s plus 3 is equals to a. You have a is equals to 1 by 2, we get L inverse of 1 by 2 divided by s plus 1 plus it is b is equals to, we have b is equals to minus 4, minus 4 divided by s plus 2, c is equals to 9 by 2 divided by s plus 3, which is 1 by 2 L inverse of 1 by s plus 1 minus 4 L inverse of 1 by s plus 2 plus 9 by 2 L inverse of 1 by s plus 3. So it is 1 by 2 e to the power of minus t, e to the power of minus 2t plus 9 by 2 e to the power of minus 3t. This is the inverse Laplace transform. In the same way, you are trying to complete these problems. Yes, how we are going to, how you are decomposing into partial fractions, that is very important. Write some problems on this. L inverse of 1 plus 2s divided by s minus 1, s minus 2. L inverse of 1 by s plus a, s plus b. They are the simple fractions. L inverse of 2s square minus 6s plus 5 divided by s cube minus 6s square plus 11s minus 6 L inverse of same 2s square minus 6s plus 5 divided by s cube plus 6s square plus 11s plus 6. Here it is 1 minus 1 minus, here it is plus 12, that is minus 1 is the root. Next, seventh one, L inverse of s square divided by s square plus a square into s square plus b square. See, now coming to seventh one. Here this can be written as in here it is s square plus a square, two roots we have, plus or minus ai plus or minus bi. Generally we are writing s plus ai, s minus ai, s plus bi, s plus s minus bi, that is more complicated. So in that case, in order to overcome the situation, I am going to write s square divided by s square plus a square into s square plus b square is equals to, yes, for this problem I am writing here s square plus a square plus b divided by s square plus b square. This numerator and denominator in the LHS, it is a function of s square. So I am going to write in a linear case, put s square is equals to some x I am taking. After getting the results, I am replacing x with s square here. So this can be written as so this equation becomes x divided by x plus a square or a square plus x plus b square is equals to a divided by x plus a square plus b divided by x plus b square. So this is equation number 1. Multiply 1 with I am multiplying with x plus a square here, x plus a square on both sides and taking x tends to minus a square. So it becomes, here it is x plus a square get cancelled, x tends to minus a square, we will get the a limit x tends to minus a square. Here x square plus a square get cancelled, we have x divided by x plus b square we have. So which is x is what, minus a square divided by b square minus a square, this is a. Next, multiply 1 with x plus b square on both sides and taking x tends to minus b square. So yes, there is no particular method for finding the inverse Laplace transform. How we are going to find the Laplace transform? By minimizing the steps, that is very important. Yes, if you go for this one, if you are applying the convolution theorem also, you will get, later we will discuss, further we will discuss. But before that, we don't have any just basic fundamental properties we have. Based on that, I am trying to solve the problems. If you go for this first shifting theorem, second shifting theorem, followed by the change of scale property, derivative multiplied by t to the power of n, division by t, so many properties are there which are exist in the Laplace transform. Same will be we are writing in the inverse Laplace transform also, right? Here it is, we only some 8 principles, based on that 8 principles I am trying to solve this one. So in this b is equals to limit x tends to minus b square here it is what we have, x divided by x square plus x plus b square, x plus b square it cancel, we have x square plus b square, so which is minus b square divided by, so not here, a square here, a square. So we have a square minus b square, no? Yeah, a square minus b square, it is a square minus b square. So we have a and b. So now I am going to substitute a and b here. So this equation becomes a is minus a square divided by a square minus b square, b is plus minus b square divided by b square minus a square, by x plus a square by x plus b square. Now I'm going to replacing this can be written as better to write like this a square 1 by if you common a square minus b square if you common so we have it is if you common minus here a square minus b square minus minus get cancelled b square divided by x plus b square that is s square plus b square. Is it clear? Minus a square divided by x plus a square s square plus a square. So now here this is the s square divided by s square divided by s square plus a square into s square plus b square. Now taking the inverse Laplace transform on both sides, yes, here it is, here we will get this one, so which is 1 by a square minus b square is L inverse of, so I am writing 1 by b here, 1b, or if I am commoning b here, first case b into is L inverse of b divided by s square plus b square minus a into L inverse of a divided by standard principle we have s square plus a square, so which is 1 divided by a square minus b square, so which is b cos or sin bt minus a cos a sin at, a sin at. This is a way of finding the inverse Laplace transformation. Next, right, next, or maybe some minus or plus, see what's check it once. Next, next problem, L inverse of 1 divided by s plus 1 into s square plus 1, 1 divided by s plus 1 into s square plus 1. So here it is 1 divided by s plus 1 into s square plus 1 is equals to, here only one linear root and these roots are different, so we can write a divided by s plus 1 plus bs plus c divided by s square plus 1. You go for a general method, right, which is same as that implies this can be written as this, say this as equation number 1. 1 is equals to a into s square plus 1 plus bs plus c into s plus 1. Now equating the coefficients of s square s and constant s square s on both sides. So s square coefficient as nothing is there, here it is s square coefficient is a is there, here it is bs into s, it is bs square, that is a plus b is equals to 0, first equation. Next, s coefficient, yes, here it is cs plus, it is s plus 1 here, cs plus bs, that is b plus c is equals to 0. Next, constant terms a plus c, here constant terms, here it is a bs square, next bs c, a plus c is equals to 1. So if you take this one, a is equals to what we have, a is equals to minus b from this equation. If you write a is equals to minus b, yes, this becomes minus b plus c is equals to 1. If you write this one minus b plus c is equals to 1, adding these two, 2c is equals to 1, that implies c is equals to 1 by 2 here. C is equals to 1 by 2, then b is equals to is c minus 1. So it is c is 1 by 2 minus 1, which is minus 1 by 2. Next, b is equals to minus 1 by 2, a is equals to 1 by 2. Therefore, a is equals to 1 by 2, b is equals to minus 1 by 2 and c is equals to C is equals to 1 by 2. So if you are substituting this, 1 divided by s plus 1, s square plus 1 is equals to 1 by 2 divided by s plus 1 plus b into minus 1 by 2 plus 1 by 2 divided by s square plus 1. So here which is L inverse of 1 divided by s plus 1 s square plus 1 is equals to 1 by 2 into L inverse of 1 by s plus 1. Next here b is it is bs minus 1 by 2 into L inverse of s divided by s square plus 1. Next 1 by 2 plus 1 by 2 into L inverse of 1 divided by s square plus 1. So this can be written as 1 by 2 into e to the power of minus t minus 1 by 2 into s divided by s square plus 1 square. It is cos at, that is cos t. A divided by s square plus 1 square. So it is 1 by 2 into sin at, that is sin t. This is the evaluation process. Next. Next, if you take another problem number, here it is L inverse of, right, s divided by s square plus a square, s square plus b square. We did the same problem, but numerator is s is there. So in this case, just you write it, s divided by s square plus a square into s square plus b square is equals to as plus b divided by s square plus a square plus cs plus d divided by s square plus b square. Equating the coefficients of here s cube, s square, s and constant, you will get a, b, c, d, right? Then you will get these values. The roots are imaginary, so this is the way. Next. Right, first shifting theorem, but you know that I recall the statement of the first shifting theorem in Laplace transform. If Laplace transform of f of t is equals to f of s or f bar of s, then Laplace transform of e to the power of at into f of t is equals to f bar of s minus a. Here, listen. Now I am writing this can be written as in case of inverse Laplace transformation. If L inverse of f bar of s is equals to f of t, then L inverse of f bar of s minus a is equals to e to the power of at into f of t. This is the first shifting theorem. Or as L inverse of f bar of s is equals to f of t, then L inverse of f bar of s plus a is equals to e to the power of minus at into f of t. This is the first shifting theorem. That means it is combined with the exponential, right? Now coming to some problems on this. That means some examples we are taking here. Yes, you know that Laplace transform of s divided by s square plus a square is equals to what you are going to write. Here it is cos at. Suppose if we have Laplace transform of s minus b divided by s minus b whole square plus a square. That means s is replaced with s minus b. So you are going to combine the f of t with e to the power of at. Here instead of a, here b is there. So what you are going to expect here, e to the power of bt cos at. Suppose if we have L inverse of some 1 divided by s square plus a square is there. What I am writing? 1 by a into sine at here. Here if we have L inverse of 1 divided by s minus b whole square plus a square. So here it is 1 by a into e to the power of bt sine at. Right, s is replaced with s minus b. Sometimes if we have like this also, no problem. Here it is a divided by some s minus c whole square plus d square. What you are going to write here? 1 by a will a not a, it is some a square is there. A square is there, some b is there. So we can write it. We don't expect this term. So here it is e to the power of bt sine at, same, right? By using the first shifting theorem, here it is s, the term s is replaced with s minus b, will get e to the power of bt, right? In the same way we can write it all the formulas from starting to now coming to the problem. L inverse of, evaluate L inverse of 1 divided by s square plus 8s plus 16. 1 divided by s square plus 8s plus 16. You may write it, this can be written as, if you go for the partial fractions also you will get that one, right? Without writing the partial fractions, I am trying to apply this can be written as here it is s plus 4 whole square. Listen, you know that L inverse of 1 by s square I am trying to recall. Yes, it is a positive, right? It is L inverse of 1 by s to the power of n plus 1 is equals to, here t to the power of n divided by n factorial when n is a positive integer. L inverse of 1 divided by s to the power of 1 plus 1 here is equals to t to the power of 1 divided by 1 factorial, which is equals to t Laplace transform of, here it is s, instead of s what is there, s plus 4 is there. So s is replaced with s plus 4. That means which term you are going to add, which term you are going to combine here, e to the power of plus 40 or minus 40, minus 40, here positive is there. By first shifting theorem, L inverse of 1 divided by s minus of minus 4, that is the reason, right, is equals to e to the power of minus 40 into t. Without expanding the partial fractions also we can get this one, right? Next, if you go for the next problem, L inverse of 1 divided by, the same way, 1 divided by s square minus 6s plus 10, s square minus 6s plus 10. See this can be written as L inverse of 1 divided by s square, just on inspecting, right, on inspecting the given denominator, here it is minus 6s, I am writing plus 9 plus 1. 10 can be written as 9 plus 1, no? Which is L inverse of, that means we get some formula here. Here it is s minus 3 whole square plus 1 square. Did you get an idea here? Just now I written L inverse of s minus b whole square plus a square. Here it is, we know that L inverse of 1 divided by s square plus a square is equals to 1 by a sine at. L inverse of 1 divided by s minus b whole square plus a square is equals to 1 by a e to the power of bt sine at. S is replaced with s minus b, same, right, which is equals to 1 by a, that is 1 by 1, e to the power of bt, b is equals to 3 is there, e to the power of 3t sine t. This is the, right, without writing, you may write it, this can be written if you are expanding into this is, I think this problem is not possible to expand into partial fractions here. S square minus 6s plus 10 factors are not getting directly, so we can write in this form, then we'll get the function of t like this. Next, Yes. Find the inverse Laplace transform of 1 divided by s square plus into s square plus 1. That means evaluate L inverse of 1 divided by s square into s plus 1 whole square. S square into s plus 1 whole square. First I am decomposing to partial fractions, then taking inverse Laplace transform. 1 divided by s square s plus 1 whole square is equals to a divided by s, b divided by s square, c divided by s plus 1 plus d divided by s plus 1 whole square. So this is 1. Next, so this can be written as or multiplying both sides with a s square and taking s tends to 0, multiplying both sides with s square and taking s tends to 0. So we have this term is completely 0. We have s square get cancelled, s square multiplying with s square by s only s we have in the numerator, and s tends to 0, this term becomes 0. S square we have c d becomes 0, s square get cancelled, we have only b, limit s tends to 0. Here s square get cancelled, 1 divided by s plus 1 whole square, which is nothing but 1. Next, multiplying both sides with s plus 1 whole square and taking s tends to minus 1. So here the s plus d we have, d is equals to limit s tends to minus 1, s plus 1 whole square, s plus 1 whole square get cancelled, we have 1 by s square, 1 by minus 1 whole square is nothing but 1. Next, if you go for put s is equals to 0, if you go for that one, a into s square plus b into, if you write like that, here that means b is equals to 1 we have, d is equals to 1 we have. Or if you write this 1 is equals to a into s plus 1 whole square plus b into s plus 1 whole square plus c into s plus 1 into s square plus d into s square. So put s is equals to 0, put s is equals to 0, these three terms become 0 here. Listen. After getting c and d, that equation 1 becomes 1 divided by s square s plus 1 whole square is equals to a divided by s 1 by s square, c, that is c divided by s plus 1 plus d divided by d is equals to 1 we have, here it is s plus 1 whole square, say this is 2. Put s is equals to 1 and s is equals to minus 2. By solving into these equations or equating the highest degree terms, better to equate the highest degree terms, right? So we have 1 is equal to LCM is same, no? Better to s plus 1 whole square, this is the way. Next, plus s plus 1 whole square plus c s square into s plus 1 plus s square. Now equating the highest degree terms on both sides, here is s square we have s cube, the terms on both sides s cube, it is a we have a. Next, here s square, here it is plus c is equals to 1, sorry nothing, 0. So a plus c is equals to 0, so a is equals to minus c, leave it. Next, if we go for s and next we go for s square we have here a plus 1 plus c, H 0 is equals to a plus 1 plus c plus 1. So here it is a plus c plus 2 is equals to 0. Here it is a is equals to minus c we have. So here by solving these equations you will get a and c. Here a is equals to minus 2 we will get and c is equals to 2 we have. So if you are substituting this, a is equals to b is equals to d, c is equals to and d is equals to. So here it is 1 divided by s square into s square plus s plus 1 whole square is equals to a is equals to minus 2 divided by s plus b is equals to 1 divided by s square plus c is equals to 2 divided by s plus 1 plus d is equals to 1 divided by s plus 1 whole square. Taking inverse Laplace transform on both sides, 1 divided by s square into s plus 1 whole square minus 2 into L inverse of 1 by s plus L inverse of 1 by s square plus 2 into L inverse of 1 by s plus 1 next plus L inverse of 1 by s plus 1 whole square. So which is minus 2 into L inverse of 1 by s, it is nothing but 1. L of 1 is equals to 1 by s. Here it is t plus 2 e to the power of minus t. As here it is here t e to the power of minus t. This is the answer. Yes. So you know that the partial fractions, decomposition of the partial fractions. Next. Yes, we try to solve these problems. Yes, this can be written as, for this problem, s square minus 2s plus 2 s square plus 2s plus 2 is equals to 1 by 4 into 1 by s square minus 2s plus 2 minus 1 by s square plus 2s plus 2. If you take out LCM, s square plus 2s plus 2 minus s square plus 2s minus 2. If those two terms get cancelled, 4s divided by 4, that is s we have. Now taking the inverse Laplace transform on both sides, for the inverse Laplace transform of this one, 1 by s square minus 2s plus 2 minus 2s plus 1 you can write it. 2 can be written as. Here also plus 2s plus 1 you will get the answer easily, right? Try to solve this one. Next class we go for the finding the inverse Laplace transform by applying the remaining theorems. Again you may try for this problem also, right? Fourth one, L inverse of, right, s divided by s to the power of 4 plus 4a to the power of 4. L inverse of 1 by s into s square plus a square. L inverse of s by s to the power of 4 plus s square plus 1.